Welcome back. Today, we're diving into a design pattern that is, and I'm not exaggerating, an absolute game changer for anyone building modern software. Seriously, if you work with microservices, or you're just curious how these massive, sprawling applications actually hold themselves together, then the Saga pattern is something you've just got to understand.
So let's start with the problem that you've probably never even thought about, but it's one that keeps software engineers up at night. And it's all about making sure that a simple online order doesn't accidentally, break the entire system.
Think about it. When you click that place order button on your favorite website, what's really going on? I mean, it feels totally instant, right? Just one single action. But behind the curtain, it is a completely different story. That one little click, it kicks off a whole chain reaction. It's not one big program doing everything. Nope, it's more like a team of highly specialized experts. We call them microservices. First, the order service creates the order. Then, it hands off to the payment service to deal with the money. Once that gets the green light, the stock service gets a ping to go reserve your item. And finally, the shipping service is told to get a box ready. Each one of these is its own separate, independent application. And right here, this is the critical question. What happens if, say, the payment service fails after the order has already been created? Or what if the item goes out of stock after your payment has been processed? You can't just leave the system in this weird, broken, half-finished state. That would be total chaos. We're talking money taken for no product or orders logged for payments that never went through. A real mess.
Now, back in the old days of these single giant applications, what we call monoliths, you'd solve this with a really rigid database transaction. It would basically lock everything down until every single step was complete. But in the super fast, super flexible world of microservices, that approach is a massive bottleneck. It's way too slow, and it ties all your services together, which kind of defeats the whole purpose of using them in the first place.
And this is where our hero enters the scene. The Saga pattern is the elegant, modern solution to this whole distributed transaction problem. It's how you maintain that crucial data consistency without grinding your entire system to a halt.
So, what is it exactly? Well, Saga is really just a sequence of local transactions. Each microservice completes its own little task, like processing a payment, and when it's done, it kicks off the next step in the sequence. It's like a controlled chain reaction.
This brings us to the absolute secret weapon of the Saga pattern, the compensating transaction. Here's the deal. For every single action in the sequence, you also have to define an action that can undo it. So, if you reserve an item from stock, the compensating transaction is to release that item back into stock. This is how a Saga cleans up after itself when things go wrong. It's brilliant.
Okay, so we know a Saga is a sequence of steps, and each step has an undo action. But how do you actually manage that whole sequence? Well, there are two really popular styles, and they have completely different philosophies: choreography and orchestration. At a high level, it all comes down to control. In choreography, there's no central boss. Services just kind of broadcast messages or events, and other services listen in and react. In orchestration, there is a central boss, a coordinator that tells everyone exactly what to do and when.
Let's start with choreography. I want you to think of it like a dance floor. When the order service is done, it basically shouts out, "Hey, order created." The payment service hears that, does its job, and then shouts, "Payment processed." Each service just knows what events to listen for and how to react. They all work together beautifully without any central director telling them what to do.
Now, the beauty of this approach is how simple and resilient it is. It's super easy to add a new dancer to the floor, and there's no single point of failure. If one dancer leaves, the party doesn't stop. The downside, though? It can be really hard to see the whole dance from the outside. Trying to debug a problem can feel like trying to figure out who stepped on whose toes in a really crowded room.
The other approach is orchestration. Okay, now picture a symphony orchestra. You've got a conductor right in the front. That's the orchestrator. And that conductor has the entire musical score. The conductor points to the payment service and says, "You're up," then points to the stock service and says, "Now you." It controls the entire flow from one central spot.
The huge advantage here is clarity. The entire business process is spelled out in one place, which makes it so much easier to understand and to debug. The risk, of course, is that the conductor becomes a single point of failure. If the conductor goes down, the whole symphony just stops. And you have to be really careful not to make the orchestrator too smart, or you'll accidentally build another complex monolith.
All right, theory is great, but let's make this stuff real. We're going to go back to our e-commerce order and actually watch a Saga play out. both when things go perfectly and when they go very, very wrong. First up, the happy path. The Saga starts, the order service does its thing, done. It triggers the payment service, which succeeds, great. That triggers the stock service, it succeeds, the Saga is complete, and the order is confirmed. Beautiful, simple, and it just works.
But what if step 2 fails? The customer's card is declined. The payment service fails its transaction. Now this is the moment of truth. This is where the Saga pattern really shows its power. The system can't just stop here, right?
And here comes the rollback. This is the magic. Since the payment failed, the Saga starts running those compensating transactions, but in reverse order. So if the stock had already been reserved, it gets released. Then the original order is marked as canceled or failed. And the end result? The system is back in a perfectly consistent, clean state. It's like the order never even happened. No data corruption and no angry customers.
So now that we've seen it in action, let's kind of zoom out. The Saga pattern is incredibly powerful, but it's not a silver bullet. It absolutely comes with its own set of trade-offs, and it's really important to know when to actually use it. This table draws the contrast perfectly. You know, traditional transactions, we call them ACID transactions, they give you perfect data isolation, but they force you into this tight coupling. Sagas, on the other hand, give you that crucial loose coupling you need for microservices, but you trade away that perfect isolation. And yeah, implementing a Saga is definitely more complex. It's the right tool for distributed systems, not so much for a simple single database app.
So when should you reach for this pattern? Well, you should use it when you have a business process that spans multiple services and might take a long time to finish. If you absolutely have to maintain data consistency across those services and you value resilience and loose coupling above everything else, then the Saga pattern is probably your answer.
This quote just nails it. You should think of a Saga as a recovery pattern. It's your system's insurance policy. It makes sure that even when individual parts fail, the system as a whole can gracefully recover and keep its data in a good, consistent state.
And that leaves us with the final question, the one you have to think about. The Saga pattern gives you immense power to build these resilient, scalable systems, but it also adds complexity to your design, to your code. So as you think about your next project, you have to ask yourself, is that trade-off worth it for you? Thanks for tuning in.